Welcome to Physics of the Fidget Spinner. My name is Samantha Benelli. I'm the Physics and Engineering Specialist here at Ward's. The science of the fidget spinner is broken up into two modules. We have an elementary and middle school level, and we have a high school level. So I was going to start with elementary and middle school today. Just to start you off, I want to let you know that both of the levels are aligned to NGSS standards. They are listed on the PowerPoint here. You can request that when we're all finished today by emailing our tech support team. I'm not going to go through and read every single NGSS standard to you that it's aligned, but just want to let you know that it is aligned and that information will be available to you at a later time when you want the PowerPoint. So the overview and objectives of the elementary fidget spinner kit. This kit is designed to help students learn about the effect of force on the motion of an object, as well as seeing the effect of mass on a rotating object. So I wrote here qualitative in nature, and that's because the elementary kit obviously doesn't dive into a whole lot of math concepts yet. This is going to be more observing the motion of the spinner and kind of thinking about the physics of what's happening. In this kit, students will determine the effect of force on the speed of the spinner. We're going to observe the mass of the spinning object and how it affects the force needed to start and stop it from spinning. We're going to feel the forces that a spinning object exerts as it's rotated. And we're going to experience the effect known as the wagon wheel, which feeds into the idea of persistence of vision. So some relevant vocabulary that the elementary and middle school kids are going to be learning with this exercise. First is force, a push or pull on an object, usually resulting in some kind of motion. Next is friction, the resistance to motion when one surface is sliding across another. Impulse, my favorite, I don't know why, it just is. A force acting on an object over a specified period of time. A force working on an object over a short period of time is said to have the highest impulse, whereas compared to the same force over a longer period of time with a small impulse. We're going to be talking about pivot, the central point, pin, or shaft which a mechanism turns, rotates, or oscillates. Tolerance, the amount of variation on an object that is allowable in order to still have the object function correctly. Last but not least, we're going to be talking about torque, the amount of force acting on an object that causes it to twist or rotate around a pivot point or axis. Just some background in general about fidget spinners and how they operate. This background information is the same in the elementary kit as well as the high school kit, so this content is the same across both. First, fidget spinners come in different styles, but at the core of them all are ball bearings, these little black pieces. The bearings allow the outer ring to rotate freely around the inner ring. And the quicker the force is applied, the faster the spinner will rotate. And once in motion, all fidget spinners eventually stop. No matter how good the bearings are, eventually friction comes in and eliminates the rotational energy and brings the spinner to a halt, eventually. So procedure number one, we're going to introduce force and motion. So the first part of the procedure is the kids are going to flick an arm of the spinner lightly and measure the time it takes for the fidget spinner to stop spinning. I did this earlier. I put some sample data in here so that we didn't have to wait the entire time for the fidget spinner to stop. So earlier mine was about 16 seconds when you flick it lightly. And this was probably about 12. I flicked it way later this time. So the students would record their data there. And then the second time, you'll want to flick it as hard as possible and then measure the time for the spinner to stop. So earlier, my hardest possible was 37 seconds. This one is probably going to be a little less than that because I have these fancy thumb holes in my jacket, so it just kind of hung up on my thumb hole there. So I did record the data for you there so that we didn't have to wait until the fidget spinner stopped. So then the students are asked, why did the light flick produce less time of spin, and why did the quick flick Why is that going to go way longer? And it's because we applied more force the second time. So it's going to be way more time before friction really has a chance to slow it down. So procedure number 2 in the elementary side is inertia. Yay! Again, I have no idea why I love inertia so much, but it's a pretty word, maybe. I don't know. So the second part is flick the spinner and measure it just regularly, not, I guess, your standard flick, if you want to call it that, not too softly, not too hard, just record that data. And I did that earlier at about 23 seconds, so it was my medium speed there. So the part with the inertia is kind of fun. I have silly putty. You don't have to use silly putty. I have it at my desk, so when I'm a fidgeter, so this is actually a perfect lab for me to do because I'm either doing this at my desk or I have silly putty in my hand and I'm just constantly using it. I am definitely, like, this was made for me. I know there's something else sometimes, but I'm definitely the ideal customer for these. So with the silly putty or clay or whatever malleable item you have in this similar nature, you'll want to break it up into 3. Silly putty's kind of hard because it stretches so much, but you'll want to break it up into 3 equal pieces. That one's a little small. Okay, and you'll want to roll them into a ball. And then we'll want to take the putty and insert it, not completely into the bearing hole, but just enough so that it's completely covered on both sides. I mean, you can put it all the way through, but I figure if you're using clay, silly putty's pretty good, but if you're using clay, it might get stuck in the crevices and that'll be messy. So you'll just want to make sure that everything is covered. So your bearings are completely covered on both sides. And then we're going to flick this. You'll have to remember to use the same amount of power to flick this one that you did last time. So that's why I say do your standard one. Don't try to make it harder or softer. Just try to flick it naturally so that you'll remember how to do it the second time as equally as possible. So the idea here is that, and I just touched it, so I'm not really showing you the exact idea, but the idea here is that with the silly putty covering the bearings, that displays inertia because the spinner is going to spin slower and it's going to stop faster than just the average flick. So if you wanted the spinner with the additional clay to spin for the same amount of time, what would you do differently? And that's when the students would say, well, in order to kind of combat the inertia that's happening, you'll flick it. I'm sorry, I just got in my own brain. You'll want to flick it slower so that it takes less time.